Okay, pre-calculus, this is the second video for 4.4. We're going to be doing all these problems where we're finding the value of the trig function without a calculator. I'm going to be using the Microsoft Whiteboard. And again, I'm bringing back what we had talked about. We basically have two triangles. The 30, 60, 90 triangle. Short leg is a half, long leg is √3/2, hypotenuse 1. And the 45, 45, both legs are the same. They're both √2/2, hypotenuse is 1. So for the first problem, cosine of -π/2. Okay, first step on all of these, figure out where my angle is. So π/2 is 90 degrees. Going back to our unit circle. π/2 is 90 degrees. So negative π/2 would just be negative 90 degrees. So remember, I'm thinking of this like a spinner. And this spinner is going to land facing straight down. Now, I can't even draw a triangle here. I'm always going to try to draw my triangles to the x-axis, but I can't because I'm already on the y-axis. I would just be drawing right over my own line there. When I land on an axis, things are actually easier. Remember that on the axis, remember this spinner has a length of 1. It is a radius of unit of 1 length. These are the coordinates, 0, -1. It wants the cosine. Remember that the cosine is the x-coordinate. So the answer to this problem is 0. And we're done. For the next one, actually, let me turn off this ink to shape because that's going to mess things up. For the next one, we have the tangent of 5π/6. So first step is to look at your angle and figure out where does your angle land. Every over 6 is 30 degrees. So as I was talking about the unit circle, if I know that 30 degrees is 1π/6, if I consider that to be 30, that's 1π/6, 2π/6, 3π/6, 4π/6, 5π/6. So the angle terminated right here. This is going to build a triangle now. I always build my triangle to the x-axis. This reference angle is 30. That was 1 tick away from getting back to the x-axis. Well, now I can use my 30, 60, 90 numbers. Half, the √3/2, and 1. I know that tangent is opposite over adjacent, which would be 1/2 over √3/2. If I'm dividing by a fraction, I'm multiplying by the reciprocal over √3. Cancel. I'm left with 1 over √3, which rationalizes to √3/3. Now, the one thing I have to remember is all students take calculus. I am doing a tangent problem in the second quadrant. Only sine is positive in the second quadrant, so this answer is actually negative √3/3. That's using the triangle method to solve this. If you prefer, and again, it is up to you, if you want to have all of these figured out and memorized, and again, this would be a no calculator part, but when you start the exam, I'm fine with you writing this out. There's my angle. Remember, these go cosine followed by sine. I told you in the last video that tangent is sine over cosine. So that would be 1/2 over negative root 3 over 2. There's that negative. And I would do the exact same process. So whether you want to think of it as a point that you're working with, or you want to think of it as a triangle, it's your pick. I prefer the triangle because I like using SOHCAHTOA. But it really doesn't matter which one you pick. Okay, so for letter C, now it wants the cosecant. Okay, we haven't dealt with the inverse trig the reciprocal trig very much. Again, 5 pi over 6, well, that's 1/6, 2/6, 3/6, 4/6, 5/6, exact same angle I was just at. So that's where my spinner would stop. Same right triangle, 1/2, root 3 over 2. Hypotenuse is 1. We don't really have to write the hypotenuse to be 1 because we know it's always 1, but I'll keep writing it for a little while here. Now it wants the cosecant from this reference angle. Now, be careful, my all students take calculus thing, that only applies to the 3 main ones, sine, cosine, and tangent. But remember that cosecant is just 1 over sine. So if the sine is positive, the reciprocal of the sine will also be positive. So this answer will be positive. And again, cosecant is just the flip of sine. Well, the sine would be 1/2 over the hypotenuse, which is 1. So just 1/2. So the cosecant would be the flip of 1/2, which is just 2 over 1, or 2. Again, you could also use the point instead if you have it memorized. If you know cosecant is the flip of sine, remember the sine is the y coordinate, I would flip the 1/2, and that would give me 2. For the next one, now we're looking at it in degrees, but it doesn't matter if we're in degrees or radians. We still do the same thing. This one wants the sine of 315 degrees. Well, 315 is down in the 4th quadrant. It's a 45-degree angle reference. So I'm going to build my 45 triangle. I'm using the 45 reference triangle I've got drawn up there. Know that both sides are root 2 over 2. Again, the hypotenuse is 1 if you want to write it, but you don't have to. So again, I basically just took this triangle and I rotated it around. Well, sine from the angle would be opposite over hypotenuse, but again, with the hypotenuse being 1, I don't really care about it. This would just be root 2 over 2. Don't forget about all students take calculus though. Only the cosine is positive in this quadrant, so the sine must be negative. Again, if I want to use my points instead, 315 degrees, I wanted the sine is the y coordinate, and there it is, negative root 2 over 2. Now the next few problems get some kind of funkier angles in them. on the next one, I didn't really letter them. On the next one, we have the cotangent. So another one of those reciprocal functions of 5 pi. Okay, again, the first thing is to figure out where this angle is. Where does it land? Well, 5 pi is actually more than a full spin. I wouldn't worry about drawing this, but every half circle or half rotation is a pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So I don't care about all those extra spins. What I care about is that my spinner landed over here. Remember, if I'm on an axis, it actually makes life easier. I just look at the coordinates of the point no matter what. These coordinates, since the spinner has a length of 1, these coordinates are negative 1, 0. Now remember, cotangent is the reciprocal of tangent. So if tangent is sine over cosine, then it makes sense that cotangent would be cosine over sine, which is negative 1 over 0. We can't do that. It's undefined. So the cotangent of 5 pi is undefined. The next one is another funky angle. Cosine of negative 31 pi over 3. Now, one thing I will warn you about, if I give you an angle that's over 3, I would make it over 6. So I mean, turn this angle into a fraction that's over 6. So instead, I'm going to multiply top and bottom by 2. Oops. Make this negative 62 pi over 6. Now, the only reason I did that is because I told you guys when we were learning about the angles in the unit circle to count by 1/6 increments, not 1/3. So just to do my counting method properly, I need it to be over 6. So this is a whole lot of spins. It's a negative angle, so it's rotating clockwise. And it's a whole lot of spins. Again, don't draw all this, but every full spin would be 12/6 pi in the negative direction. So that's 12 over 6. That would be 24 over 6, 36, 48, 60 over 6. Okay, so there's 60 over 6, all those spins. Again, I don't really care about all of those spins. Keep in mind that that was 60 over 6, though. So that means the next 30-degree increment would be 61 over 6. The next one would be 62 over 6. So again, basically this spinner spun around a whole bunch of times, I think 5 times, and then landed there. 62 pi over 6, negative. But all I really care about is where it landed. It landed 2 ticks away from the x-axis, so that means it's a 60-degree reference. It's the exact same triangle, it's just been kind of flipped around and rotated, where the short leg is still a half, the long leg is √3 over 2. This one wants the cosine. Cosine from the angle is the adjacent, which is 1/2. And according to all students take calculus, cosine is positive down here in the 4th quadrant. So my answer would be positive 1/2. If you're looking at the points on the unit circle instead, again, we know we spun around a whole bunch, so we really couldn't use the circle for that. But what matters is it landed there. I wanted the cosine, which is the adjacent. Excuse me, which is also the x-coordinate. Oops. So again, if you want to use the points, if you want to memorize them all, great. If you want to use the triangles, great. Whatever way works better for you. For the next one, we have secant of 600. So again, we're spinning a whole lot more than just, well, more than once around. Oops, not sine, secant. So again, it's one of these reciprocal functions, but that's okay. Basically, if you're given a reciprocal function, figure out its normal one and then flip that answer. Well, 600 degrees is more than 360. So if I think about this, if I were to subtract off 360, that would leave me with 240. So this is a full spin and then 240 more degrees, which will put me down here in the third, in the third quadrant. So my angle terminated down here with a 60-degree reference. So again, I'm using the same triangle. Adjacent's a half, opposite's √3/2. This one wants secant. Secant is the reciprocal of cosine. Well, the cosine is a half. So the secant is going to be the flip of that, which is 2. But then again, don't forget about all students take calculus. Now be careful again. Remember, this is saying the sine is positive. Oh, no, I'm in the wrong quadrant. I'm sorry. Try that again. This is saying the tangent's positive, which means both the sine and cosines are negative. So again, if the cosine is negative, the secant would also be negative. So that's why it was -2. Okay, we'll do one more video for these last few problems for 4.4.